Okay, so what we're looking at here is the code that I built in the video that some of you didn't watch. So the first thing to pay attention to, and I'm just going to go through this again because it's really important to hammer home how VHDL is structured. It's really beneficial to have what we call hierarchical designs in VHDL, which means you're going to have some top level module, and then it contains other modules, and each of those modules might have sub-modules, right? So like at the top level, I might have 8 adders that are all doing a bunch of adding. Then inside of each of those adders might be, so let's say at the top level I have 8 4-bit adders. And each side of those 4-bit adders are 4 full adders. And each side of those full adders is gates, right? So that's the hierarchy. As we're drilling down more and more specific, it allows you to organize your code and organize your thoughts at the same time. So this one, there's no hierarchy yet. So up here at the top, sweet, is can you guys in the back see, or do you need to move closer? If you cannot see, go ahead and move up to the first 2 rows or so, just because I want. This text is small, and I haven't found a good way to make it grow yet. Could you scoot down just 1 chair is up, or just scoot a little bit that way? I just need to make sure there's 6 feet between the 2 of you. Thank you. Okay. So up here at the top, we have, I wish I had a laser pointer, but let's see, sitting down. The library declarations. So this lets it know that I want to use the IEEE library. Specifically, I'm using the standard logic 1164. This is really a standard library. Everyone will always use this, more or less. The numeric standard is not super necessary, but there is some variation of this that you will use throughout. So the book calls out the IEEE unsigned library, I believe is the one that it likes to use. And what these do is you might have 2 different types of logic, okay? So one type of logic is just the bits, 0s and 1s. Then you're going to have what we would call a standard logic vector, which is a vector of bits. And so if you said V is 0011, and then I wanted to assign bit to V at 2, that would go and pull out a 0. Or B at 1 would pull out a 1, and B at 0 would pull out a 1, right? VHDL is what we call 0 index. So meaning the first slot in the vector is a 0. This is true for most programming languages. If you you guys are probably, if you've been around a couple of years, you may have learned MATLAB. Anyone? Good, nobody knows MATLAB, so you won't get that confused. So MATLAB is one of the few common languages that is actually 1 index. So this is, again, 0 index. So if I want the 0th bit, I would say V at 0. Okay, so what this does is these libraries explicitly allow you to add standard logic vectors together. Without it, they don't really add, and you have to use and or operations, and it's kind of annoying. So for now, just understand that these, or some combination of these, I will provide them for you. You don't have to worry too much about the specific libraries, are allowing you to do operations that you wouldn't otherwise be able to do. And if you get weird errors in your code when you start designing it that say something like about overloaded operators, it probably is because you're not using the right library. Okay. So the next thing that we want to do is talk about the entity. So this is the creation of what we would call a module. So the entity is like saying, I exist, and this is how I interact with the outside world. These are called ports. They can be input, output, in, out, or buffers. And for the most part, we are going to deal with inputs, right? So in out would be like the tri-state buffers that we talked about before, where you can kind of just kind of float the output for the output and then take it as an input. Most of the time, we're just going to use strict in and outs. We don't have a lot of need for in out in this type of design. Okay, so this is saying that I have ports AA, BB, CC, DD. These are all assigned to type standard logic, and they are in. So standard logic is just to say another way of saying bits. I could say type bit, but what I'm allowed to do with bits is very different than what I'm allowed to do with standard logic. And some professors in the past have made students suffer through using bits in this one. It's a nightmare. You can't even add bits together. Like it's just not fun. So we're going to stick with standard logic. And you'll notice that it brings up suggestions. You might have like standard logic signed is another one that I kind of mentioned, right? But then it's going to throw errors because VHDL is what we would call a strictly typed language, meaning that I cannot put an unsigned into a bit because they're different. Even if it only has one bit in that unsigned, it still can't match it because they're different types. They don't work. It's apples and oranges. A language like Verilog is very weakly typed. So Verilog, you can do all sorts of things that it just kind of lets you get away with. The downside is that it may or may not work in reality. It simulates really well and then doesn't work. And you'll run into that even with VHDL. But the benefit to VHDL, well, there's twofold. One, most of the employers around here use VHDL. So this is a real skill that real employers are going to hire you for knowing just this. The other benefit is if it works in simulation, it's more likely to work in reality than Verilog is. Okay, so let's undo that. Once you start working with Vivado, I would like you to be all aware of one little trick. If you're using hotkeys, you can use Control-Z, right, undo. Control-Y feels like it should be redo, right, because that's what it is in most languages. It is not. If you undo something you didn't need to, you do Control-Shift-Z to redo. Control-Y is like line delete or something really awful. And so you can end up accidentally deleting a bunch of your code trying to redo something, and I've seen this happen. So something I want in your floating around in your brains if you run into that issue. Okay, so these are ports. I have an input, I have a select input, and an out. This is the top level of a 4-input mux. So I have inputs A, B, C, and D, and I double these up for a reason if you watch my video. This will talk about more of the design of this. Here I'm going to do kind of the top-down explanation of this to give you a little bit different perspective. So let's say that I know I want a 4-input mux, right? Does anyone not know what a mux is? Okay, so a mux is a multiplexer. And you guys are not going to see this. Is it okay if I walk over here? And I'll look to the side. And all it's doing, this is the symbol for a mux. And I have inputs A, B, C, D. And I have 2 channel select 0, select 1. Okay. 4 inputs, select 0, select 1, output. If I put 0, 0 on my selects, it connects A to the output. If I put 0, 1, it connects B, 1, 0, it connects C, and 1, 1, it connects D. So this is how you just bring about multiple inputs to say, so say I had a full adder or something, and I only wanted to design one of these, and I only ever needed to use one at a time, then I could use the mux to choose which one I'm adding into this full adder. There's just a way of routing tasks.
So in this program, you're making
this.
that? Okay.
So we're going to start with the assumption. Say that I gave you an assignment and said, let's make a 4-channel Mux, right? And I may make you do this. I've done this a little bit of weird way, and you'll see why. And I'll make you design it a little bit differently for a homework, for example. But so let's start with this. I know that I need inputs A, B, C, and D. I've called them A, B, D, C, C, D, E, because anytime I use single letters, I really like to double them up because it makes it easier to search. And it makes my errors a little more clear.
So you could have used anything.
I could name anything, right? So I could, I mean, if I want to go crazy, I could call it flower, and it would be just fine. The only thing I can't do is use reserved words. So I can't call it bit, because bit is what we call a reserved word. Okay, so let's go back, call this AA, select, and then I'm using C out, because C is an output, just right, that's all it is. And then I have selects. So the select is a little bit different because it is a standard logic vector, because there's more than one bit in my select. So I say it is of type standard logic vector from 1 down to 0.
Oh, so you're saying instead of having select 0 and select 1,
I've bundled them together into one vector.
and you're saying that it's from 1 down to 0.
Yes. And the reason we do 1 down to 0 is that puts the most significant bit on the farthest left.
Okay.
So I could say up to, but then my most significant bit is on the right. And that would be like writing 100 as 001. Right? That gets confusing. So that's why we use the down to notation. Okay. Now this is where it gets confusing. And I need to be very clear because even my 3610 students struggle with this. Ports are what the outside world sees. Internally, they're treated like wires that we're connecting up to various things. If I build 2 modules, I can't plug ports into ports. That would be taking Legos and butting them up with the same type of connector together, right? Like if you're building a breadboard and just mashing the 2 breadboards together. It doesn't really work. You need wires that connect them, right? So ports are where the outside world to see. Nets are what connect them together. We call nets, when they're internal like this, signals. So we declare them as signal. Generally what I do is I come back and make the signals as I need them. Because there's no way in a complex design you're going to know all the signals that you need. But you'll be writing something like, oh, I need to plug A into B. I'm just going to call it, go like, I need a signal. Its name is going to be A to B. And it's going to be a standard logic because A is standard logic, B is standard logic. Let's connect them together. So that's how I will find out what I need is I go, oh, I need to connect these together. And then I'll go and name it something useful that describes it. So these other ones that I've already declared are useful to me because I know what I was designing. But we'll move on to component. So let's say I need a 4-channel Mux and say that I am a new designer and I know how to design a 2-channel Mux. And I go, well, I know how to design a 2-channel, but I don't know how to design a 4-channel. So it turns out that I can build Now, this is not a great way of doing things because we'll notice that I have A, B, C, D, but now I suddenly need 3 selects, right? Well, we can brute force it this way. This is fine. So if I have A or B, this is just 0 or 1, and C or D is 0 or 1, and we can come up with actually some better encoding for this. that decides which one. We actually can do this type of hierarchy with AOD. Maybe I'll leave the encoding later. But just know that even though there are 3 selects, I really only need 2 select inputs. And it's just that the inputs are going to have AND or gates connected to them in order to output the right one, right? There's going to be some, what we would call encoding logic. We'll get to encoding later. But let's just say that we have select 0 and select 1, that it's going to work. It won't, but so I go and say, I know that if I need I need 3 2-channel muxes in order to make 1 4-channel mux. Okay, so now we can go, well, let's create a component. Because this component is a subgroup that I can now start plugging together. So that's what I've done in here. You're going to start noticing immediately some similarities, right? I've declared the library. Okay, it's back. All right, we have an entity. Again, it declares the ports. This time I've used single letters, A, B, C, and select. I only need 1 select, so it's a standard logic vector. Now, let's talk about the architecture. I've mentioned behavioral and structural. This is behavioral. I'm describing how it behaves. I'm not writing AND gates. I'm just writing if statements, right? So if statements, another way of saying that is conditionals. And that's what I wrote up on the board. If this, then that, okay? So the architectural behavioral of Mux is, and then I say begin. There's some stuff that you'll declare in between architecture and begin sometimes. We'll get back to that when we get to the top. But a process. So I don't want you to fret too much about this process. I did this so that I could show you one way to build a Mux without giving you an answer to a future question on the homework that you'll build. A Mux can just be used logic, right? But this is a process. All you need to know is a process reacts to what we would call a sensitivity list, and we'll dig way more into these later. But just know that the process is saying if A, B, or select ever changes, I'm going to execute this process like a function and say, what decision do I make based on when these inputs change? Okay, so then as I was saying, if my select is 0, assign the output C to A. And notice again that less than or equal to assignment statement. Otherwise, I could do else if then have equals 1. I don't need to because it's only 0 or 1. There's no other cases, right? Otherwise, C is B. And then I end if, end the process, and end the architecture. That's my whole Mux. That's all it is. So this is describing what a 2-channel Mux is doing. Okay, so the top component then, I say there is a component called a Mux with these ports. I'm letting this top level module know that it exists. That's all I'm doing here. Then, inside of the architecture begin, I create what's called an instance. So there's one instance of this Mux. I'm calling it Mux1. It's named Mux1. The part is Mux. And I'm doing what is called a port map. I'm telling it where these ports go to, right? So the port A, which is inside, and this is why I did the AA thing, because inside the port is A, right? So port A is connected to the wire AA, or the net. And then I do that, B is BB. Then Mux2 is A to CC, B is to DD, right? So now this is A to C. And that's because this is my second Mux on the left side of that design, right? So now I have 2 Muxes with ports mapped. They have repeated port names. That's okay. You need to be very careful not to repeat net names. Then I come into and I make a third Mux because I need my third Mux. And I have created signals because I was like, oh, I need to plug the outputs of these muxes into my third mux. So I need a signal to connect those two together. So I went and created signals C0 and C1 of type standard logic and connected, and this is one nice feature, right? If I double click on C0, it shows me the highlights of where the other ones are connected, right? Where the other locations of C0. So I create signal C0. The output of my first mux is C0 and plug into the input of the second tier mux. So in this diagram, this wire or net is a signal called C0, and this one is called C1. They are plugged into C out, it's a little small, in both of these cases, right? The C out is plugged into C0. C out 2 is plugged into, but it's just called C out because it's the same port, same mux. C1, and these are plugged into the ports A and B. So that's why I created those signals. Now, currently, the selects are wrong, but they're right enough to give you the idea, right? So like I said, select is a vector of length 2. Looks like we might need 3 or a decoder, but right now, let's just work with what we have. So select at 0 gets plugged in the first mux. Select at 1 gets plugged into the second mux, so that I can choose between A and B separately. I would then need a third select, right, to decide which of those two outputs to decide. So currently it's saying select at 0 is plugged into that one. That doesn't really help us very much, unfortunately, at the moment. But it's okay. There's a really pretty easy way to fix this logic. But that's how I access just one bit of a bit vector. Does that make sense to everyone? Excellent. Okay, and so that's the general idea. So then I can go on and say that I need some sort of logic in order to, I want to scroll down a little bit, in order to create, sorry, I need to look at the time. And I need a drink. If you guys run into questions, if anything's not clear, stop me, interrupt me, ask. Because this is all foundational, it's important. And I know you're not going to run into questions too quickly until you start doing some of this, so we'll try and get you onto programming VHDL sooner rather than later. All right, say that again.
Is it wrong to think of a bit vector left and right?
Not at all. It is just a two-dimensional array, right? It's 1 by n. You can create full arrays in VHDL, but that's probably outside the scope of this class, where you can have a full array, like a 2 by 2 or 8 by 8 or whatever you want. You can do that. But so as long as you picture it correctly, you're totally fine. Yeah. So there is some other things that you can do, right? So let's go and create a new signal. And we're going to call that let's just create a couple of signals just in case we need them. So this is something that is useful. So I know I need a signal S. We'll start 0 indexing. I use a lot of MATLAB in the past, so I intrinsically send it 1 index. If I do that, I will try and fix it because it gets confusing. But I will try and stick to 1. I do not need new lines for each of these, right? So up here, I created a new line for each of them, just to be clear. I can quite simply S0, S1, S2, S3, and so on and so forth, as long as they're all of type standard logic. If it's a new type, It needs a new line. So now I have all of these S's. I can start doing things with them. So like, let's say S0 gets assigned to, and we don't want to do anything else with it, A. Rather, let's say A and B. Oh, sorry, I have to do AA. So this is a really important debug skill. Notice it has that little squiggly line underneath it. If I just put my mouse over it, it will give me a hint as to what's wrong. So in this case, it says error, A is not declared. Okay, that's easy enough. It means it doesn't know what it is. And that's just because I didn't declare it. I declared it as AA and BB. Sometimes these errors get pretty cryptic. So like, say I did something and forgot the semicolon at the end of that previous line, and I moused over. It says error, syntax error near S0. Well, there's nothing wrong with my S0, right? This usually means that there's, if it just says syntax error near blank, it means that whatever came before it is a problem. This can get really confusing once you start getting lots of like if statements and then let's say processes, because then you have begin, end, and some of them will say end if, some of them say end process, some of them say end component, right? And it's easy to miss which one that is, and you kind of have to go through and make sure they're all correct, if they're all kind of like, a term that you'll hear me use is nested. So if I say like if this, then this, and then put another if statement inside that if select 0, then if select 1, do something else, right? That's a nested if statement. Something that's nice for you guys, there is something called a for loop and while loops that those of you that are familiar with programming language have seen. In digital logic, we don't use those very much. They don't turn into hardware very well. And I will explain that why later, but we'll get to that. Okay, I just want to start with the code, right? And then we'll start talking about with some of the whys and some of the meat and potatoes, so to speak. So we have this S0 is AA and BB. All right, cool. S1 then is, say, S0, which I can now use, or CC. This is where things get complicated a little bit. This is what we would call combinational logic. That's everything that we've done. There are two types. There's combinational and sequential. Sequential has a dead giveaway in that it has a clock. Combinational just has inputs that it reacts to. So what we see then is in combinational logic, these two happen simultaneously. So if S0 changes, S1 changes as a result of S0 at essentially the same time, right? It's not like one and then the other. Now there is some of that, right? Because we've talked about gate delays before, right? And this is where it starts coming in. But Vivado doesn't know what your gate delays are because it can be used with any type of technology. So it brings in this term that we call delta. So at time 0, say, S gets set to some net value. So say at time 0, AA and BB, AA is 0, BB is 1. Let's start with that, right? So A and B is false, right? At 1 millisecond, A goes high, and we end up with 1, 1. So that means S0 goes high. And then S1 would react to that S0 input. By default, it reacts 1 delta later. And by that, if you take in calculus, anyone? How many of you taking calculus? A good chunk of you, good. So the delta is just like the smallest increment forward, right? and this is, we're on a computer, so we're not going to simulate infinite number of time steps. We're going to kind of break it down into whatever a useful time step for us is. So the delta is the smallest time step that it bothered to simulate. So S0 changes, and then one delta later, S1 changes, essentially. But if you want to, if you have an idea of what your technology states, we can go in and say, after 5 nanoseconds. So I've now created a delay in this. So I'm saying that S0 now takes 5 nanoseconds to update. And I can do the same for this guy. Yeah. No, so VHDL is very case insensitive. So totally fine. So I just changed this AA. Notice how I double click on the capital AA and it also highlights the lowercase AA. That's because it doesn't know there's a difference. So and you can do the same types of things where if you have, so I have this if, right? I can change the then to full caps. Totally fine. It is good, actually, and I'm glad you asked that. A lot of times, if I remember, you'll notice that I have a capital or and a lowercase and. Is that why you asked? Yeah. I try and do my logical operators as all caps because it makes them stand out a little more. But it doesn't care. Lowercase and, uppercase and, mixed, right? You could camel case it, whatever you want, and it's just completely fine. Okay. Done vectors, we've done components, we've done behavioral stuff. If I wanted to, S3 is standard logic, right? And I want to just assign it to some fixed value like 0 or 1. Those are the only two values that it can be. I use apostrophes around it. If I don't use the apostrophes, I get an error. And the mouse over is standard logic does not match with the integer literal. That's because integers don't have anything around them. So it thinks that I'm trying to write integer 1 into a bit. So I have to let it know that, hey, this is just a bit that I'm writing into you. Similarly, if I wanted to write, so if you recall my creation, SS here is a standard logic vector. And let's say I want it to be 4 bits. So what do I declare if I want 4 bits?
4 down to 0.
How many bits is that? Yeah, so 3 down to 0. Oops, forgot a parentheses.
Does it need to be like the digit 0 or that?
I'm an idiot. Thank you. If I do dumb things and you guys get confused, call me out. Like, I'm not going to get embarrassed. Like, I'm going to make mistakes. And if you, it's better to call me out than get confused. Okay, so now we have a 4-bit vector. And I want to assign something to that. I can't just go 1, 1, 0, 1 because it's going to think that that's, well, an integer. But it's not a bit either. So we use quotation marks. Right? You can do weird things sometimes. But you can't do something like this because this one's saying 0 definitions of an operator plus cannot be determined for overloaded operators. What this is saying is that it doesn't know how to add a bit to this bit vector. Problematic. Well, we can use libraries that do there we go. SS. I do. I don't use unsigned very often, so maybe we'll come back to this later rather than debugging what I just did. Oh. We still don't like. Anyways, this is going to be your life. So straight up, I learned in Verilog. And so sometimes the things that I think I should be able to do in VHDL, I get lost and confused in. And it takes me a little bit of debugging because I've only been doing VHDL for 3 months or so now. So I don't have the natural intuition of what I'm supposed to do. If you need to comment something out, just 2 dashes, dash, comments it out. Let's turn this back to, we can leave it as unsigned. That's fine. Okay, let me see what else we need to do.
So what's the homework like? I don't think the book was detailed. Like, what's the homework like in this semester? Does it have to do with this? Like, do we need to download it? Or is it a question?
So I haven't looked at it actually, to be honest. That's a good question though, and let's get it in our mind and pull it up. I don't look. Homework number 9. This isn't chapter 7. This is chapter 9. I didn't assign you guys one of the homeworks I was supposed to. You're welcome. Okay, chapter 9, 1, 4, 6, 9, and 11. Does someone have the book now that I can just take a peek? Yep, so you're going to need to write this code. There is, I will send out a link for an alternative tool. It's like EDA tools or something like that.
So you're saying I can either write it out or I can download this and type it out.
So you can either use Vivado to do this, or you can use a website that's like edatools.net or something that they have a VHDL coding simulator. And maybe I'll create a video that just talks a little bit about that, but there's plenty of tools that do. So maybe I'll just link you a video that exists. So it's free, it's online, it works pretty well. I encourage the use of Vivado because Vivado has a bunch of really annoying quirks that is kind of helpful to get used to. But you're not gonna lose points for not using Vivado. Because, and to be honest, I don't write my VHDL in Vivado. I write my VHDL in Notepad++. Because, and I haven't updated Notepad++ for VHDL yet, so I've been writing a lot of Verilog. So right now it has an issue in the VHDL because the coloring is bad for like standard logic vector declarations. But my Verilog, if I have any open, yeah, I haven't done that yet. So something I discovered in my time in industry is if I spend a lot of time staring at bright white screens with black text, my eyes start to get twitchy. Like I developed a semi-permanent eye twitch. This scheme is the beginning. So in Notepad++, you can use like any text editor you want. I think like the Visual Studio has support for VHDL, Eclipse has support for VHDL, like almost everything has support for VHDL. The color scheme that I like to use is called Solarized Dark. So there's Solarized and there's Solarized Dark. Those two were designed by neurobiologists to be optimal colors for the human eye to stare at for long periods of time without eye fatigue. So that's what I use when I'm programming for long periods of time. It may be something that you guys want to consider as you start your careers out, because before I adopted that, I developed like a permanent eye twitch. It was really, truly awful. It made a big difference. But showing you guys code like this color is not very useful for presentation purposes, right? It's not great. So we'll use Vivado as the example. So the point is you can write it in whatever you want. If you don't want to use the online tool, I recommend downloading Notepad++. It's a pretty good, just simple, streamlined, free tool. I think Eclipse is still free too, right, guys? No one uses Eclipse? I guess you guys don't know much about software, but there's lots of free tools out there. You can tinker and find whichever one you want, and then you can use Vivado just for like the final implementation of it. Okay. You can do other like fun conditional assignments like S1. Oh wait, we haven't used S2 yet. Is equal to S0 when oh, I need a, so this one needs, now what? So this is going to be a lot of what you do, which is a lot of stupid syntax checking, right? So what I did initially, I'll walk you through the error. So in my head, S3 should work. Because that works in Verilog, it doesn't work in VHDL. It doesn't like me using a standard logic as a condition. So I was like, oh, so I have to add an equal sign. But this is saying equal to 1, the integer. It doesn't like that because, again, we're strongly typed. So I had to say that equal to 1, the bit, using apostrophes, right? So mousing over, I just figured that out mousing over and reading the series of errors that I was seeing. Because it was like the first one was like operator isn't defined for this, and the other one's a type mismatch. Okay, so now all this is saying is S2 is S0 based on S3 as an input. Otherwise, it's S1. This is another way of writing conditionals or ifs. You can do the same type of assignment in an if statement, but I can't write an if statement outside of what we would call a process. So earlier in the Mux, I showed you that process that we don't need to know too much about yet. This is how you write conditionals outside of processes. And this is what's interesting. So this is, again, back to the concept of behavioral versus structural. This is another behavioral description of a multiplexer, right? Where S3 is right now working as the select, and S0 and S1 are the inputs A and B, and the output is S2. Does everyone see that? Okay, good. Grab a drink. Okay, so there's an example in chapter 9, right? This is all chapter 9. We're going to chapter 9.1 example, and it's saying we want to write a behavioral model, which if we say that, right, we're talking about a VHDL model, for a, we're going back to an old example where there are, I didn't cover this in class, I don't think, but it's pretty straightforward, where there's a business, there are 2 keys for the business, and they only are supposed to work during business hours. So it's saying, assuming that we have these signals, key 1, key 2, and business hours, and assume that the output unlock. So we're saying if key 1 or key 2 happens, and we're in business hours, then we can unlock the door. So to do this in VHDL, we would just do, well, let's create it in the current project, right? We could create a new project, which I show you how to do in the walkthrough that I posted. But for now, I'm just going to create a new file in this project. And before I do that, I want to point this out. So right here, you see this top level module. I called it top. I do that a lot. And then underneath it, it has 3 instances of that mux that I created, named mux1 of type mux, right? So this can start showing you the hierarchy of what you've built. So this is kind of a good way of visualizing it. Okay, so we're going to click this plus button right here, add sources. Right now, the only thing you need to worry about is design sources. There are other types of things that we can make. Let's just worry about design for now. I can bring in an existing one, or I can create one. And we're going to call this unlock. This window, you can create the ports from the get-go. I rarely do that because I feel like I'm faster just to do it. So I've now created unlock. You see it pop up here. It's on the same level as top because it hasn't been put inside of top yet, right? So as far as it's concerned, it's maybe another top level, or maybe it will encapsulate top. It doesn't know yet. It doesn't know where it belongs in the hierarchy because I haven't told it. But that's fine. I just double click on it. It opens it up. It auto generates all this nice code for us, but I don't really care about doing any of that. So I'm going to delete it to keep my code clean for you guys. These libraries are so prolific that auto generates them. That's just the assumption you're going to use them. It also creates this commented out numeric standard. So we can just delete the comments. And now we have numeric standard access. This one we don't need right now. So I'm just going to delete that. It auto creates the entity for you. How nice is that, right? The entity is called unlock. So it's saying I exist, and it's suggesting for us that maybe we want some ports. What is coming into this? Well, we have key 1. We have key 2, and we have business hours. And these are all our inputs. And what type should they be? Standard logic, exactly. We also need an output of unlock. I'm actually not sure if it's going to like this because the entity is unlocked, but let's find out. Unlock is an output, oops, yeah, out of also standard logic. You'll notice I end the first line with the semicolon. The second line I don't end with it, I just end with a parenthesis semicolon. Throwing a semicolon there will cause you no end of headaches sometimes, but the error is helpful, right? It said the error says error, syntax error near parentheses, and you're like, okay, great. Looks like we're not throwing an error on the unlock. That's good. It creates this architecture for us. It defaults behavioral. The architect is, again, I'm a little bit new to VHDL. As far as I can tell, the name of the architecture is completely arbitrary. So like I can change it to blah, and still do behavioral architecture. It just doesn't care. It's an arbitrary name. You can actually end up in a situation where you create multiple architectures for one entity, but I think that's outside the scope of this class. But if I change blah here, I have to change blah there. Ta-da. Okay. Oh wow, they did this really weird. Okay, so if I have three inputs, key 1, key 2, and business hours, and I want them to unlock the door if the I have either key 1 or key 2 and we're during business hours, right? So a pretty much straightforward description verbally of what it's doing. How do I express that in terms of the HDL? Let's start with unlock. Unlock. That's my output, right? Unlock. What are our conditions on unlock? Right? So it didn't like the fact that I didn't use parentheses. That's okay, we can use parentheses. That's all.
Is that how they did it in the book?
No.
How did they do it?
So all they did in the book is they create the outputs and inputs as their own thing. So they do, we'll do this. Key 1 is an input, key 2 is an input, and business hours is an input. And you'll see this notation in the industry actually quite a bit, where you do the variable name and then label it as an input, output, or signal. And then they went and created signals. When you create signals, you do it after the architecture, but before the begin. So then you do signal of key 1, key 2, and if I was sticking, they don't do this. If I was sticking with and this is the industry notation that I'm used to, is they would do key 1S, but the book just labels it as key 1, key 2, unlock, and these are standard logic. Oh, apostrophe. And then I'm just going to change this to business. And then after they have that, then they explicitly call out, because they want active lows. Oh, that's an output, sorry. It's like that. And because we're dealing in strictly combinational logic, all of these will execute at the same time.
So that's how they look in the book.
Because they're doing a transition between active low and active high logic. And that's all this not is doing, which again, I'm sorry, I should try and stick to full cap notation. This makes sense to everyone. If this makes sense, you're on a good path forward to being able to start doing something with VHDL, where I'm going to say the homework is like write VHDL for this. And you'll notice what's nice is if you do use Vivado and you create a new file, it starts with the library, it starts with an entity, starts with the architecture, and you just go and start filling in the blanks. On an exam, say for example, I will probably give you some stuff and just like ask you to write me some VHDL that does this, right? Like write me the VHDL combinational logic for this. You won't have to write like the architecture process. Or maybe I will ask for that. If I get that detailed, I would like make it an open book exam. That. Let me pull, is it this one? Okay, I'm going to post. We have a couple of minutes left. We have 7 minutes. And we're really getting to like the meat of this class, right? So very few of you are going to go and actually build a digital circuit with your hands like we did in the lab so far. That might happen for really simple things. A lot of you will end up doing something with VHDL or Verilog. And so this is starting to get really important. I might end up taking a little bit longer than this and having to like move things around on the schedule in order to make sure we get to everything. But it's very important. If you get confused, there are a fair number of tutorials on the internet for VHDL. Be careful because there are a lot more tutorials for Verilog. So you'll sometimes search for VHDL and the tutorial will be for Verilog and like, this makes no sense and doesn't look anything like I'm doing. Just be aware that the search is not always the best for differentiating those two. And I will get, hopefully, a useful lab posted. I recommend, right, we haven't had homework in a little bit. I gave you homework for free during exam time. I do recommend using this as an opportunity to start this homework early because you don't yet know how well you're going to do in VHDL. Don't think because you're good at Python that you're going to feel comfortable in VHDL. It's a different language, it's a weird language, and you may, if possible, you end up like me, where I'm really good at Verilog and comfortable and happy with it, and you give me C and it's a nightmare for me. Like, it's different languages. So I'm going to introduce, let me make sure I haven't skipped anything important, actually, if there's anything else I need to get to you. For the homework, I suspect there's going to be a requirement to do a test bench for some of these. I can actually see that again. Yes, so for so you're going to do problems 1, 4, 6, 9, and 11. Numbers 9 and 11 require the use of a test bench. I will create a video for you guys to introduce these test benches. Because I don't want to fall too far behind, and I was hoping to get them to this class, but I spent a little longer going over some of this in detail. I think it's time well spent, creating a good foundation for the understanding of what the VHDL is doing, kind of how we think about it. I will appreciate feedback from you as you start working through this homework, as you puzzle out what you do and don't know and have questions, so that I can kind of figure out where to focus my teaching, because I don't know what you guys don't know yet. And when I went through learning hardware programming, I was a junior. So I had a substantial amount of software background, and I had worked in software engineering for 6 years before I even took this class. So I don't have a comparable experience to what you guys are going to experience learning VHDL. So I will need your feedback to make sure that I can keep it making sense. That being said, I will create the video for test benches. Test bench is a really simple idea. It's you build this model up using VHDL, right? This key, for example. The test bench is just a way of creating stimulus that goes into the inputs and then creating what we call a waveform output. So I might actually have a really good example to show you in the last couple minutes. Let me write that down, actually. So I need to do a... So I guess there will be 2 videos that I'll make over the next day or 2. One that kind of introduces the EDA tools, which is the online one. So if you don't want to or can't install Vivado on your own computer. And I will create one for test benches. Oh, come on. Sorry, I guess my test benches currently are working. What's wrong with your code, right? Because a lot of times you're going to screw it up on the first try, but you'll figure it out as you go. Again, try and start the homework early. Come to me with questions if you have it. I have office hours Tuesdays, Thursdays, Fridays. If you can't make it during the times that are posted, reach out to me and I will try and find an alternative time that works for you, because this is important. Don't be afraid of the office hours. I don't bite, I promise. It takes forever.
He wants to do scale to the button. He wants to go scale to the
I mean, there's 24 gigs is what mine is.
Is there any way
So you'll discover this. Engineering hardware is, of course, let me tell this to stop recording my actually after it's done.
Say what?